Okay, so yesterday we talked about limits. Okay, yesterday we talked about, if I just go back really quick, we talked about limits that failed to exist. We talked about limits with graphs. We talked about equations. We talked about tables. Which one do y'all think is the easiest one? So that's going to be different for different people, right? I'm going to talk today about properties. That's what 1.3 is about. And then we're going to practice some more of the algebraic ones. Okay. I feel like graphs people tend to do okay on. We'll look a little bit about that today. You have a quiz Friday, and it is over 1.2. Okay. And so anything I teach you new today will not be on this quiz. This quiz is also no calculator, which means the tables stuff actually won't be on there either. All right, so properties of limits. I'm about to get real vague here. It's going to be a little weird for some of you that really like more specific examples. So I'm going to go through these properties, and then I'm going to go through a few examples. And so feel free to ask questions, but just know that this is extremely vague. I mean, look how many letters are down here. I'm not even going to be dealing with any numbers right here at all. And so one thing you got to know is that B and C are numbers, N's a positive integer, F and G are functions, and L and K are also numbers. So it's some really vague problem with some function, and when you take the limit as x approaches some number, you get some other number. All right, and that's L. And then we have another function with another limit. And what we're going to say is, assuming that we know these two limits, what other kinds of problems can we do? Okay, so scalar. Scalar just means a number, like a constant. If you already know that the limit of f of x is L, and I say, okay, now I want you to do the limit of, say, 7 times f of x, all you got to do with that number is it just gets multiplied to your limit. So if you already knew the limit was 10, and I say, okay, now find the limit of 2 times the function, it would just be 2 times 10. Okay, sum or difference is going to work a similar way. Instead of adding and subtracting your functions and recalculating the limit, you're just going to add or subtract the two limits. It gets you out of doing work, these properties. Even if you were kind of lost right now, you could kind of see a pattern. What do you think I'm going to write here for C, for the product? L times K. And what about for D? L divided by K, and here we would have to assume that K is not 0. That would be undefined. All right, so E is a little bit different. We have a power, and again, instead of taking a function to a power and recalculating the limit, what we're going to do is just say, okay, well, what was the limit without the power, in this case L, and then take it to that new power. And I know this is extremely vague. Like I said, we're going to do examples here in just a minute. Okay, composition is one that not only makes our life easier, but it's actually necessary to do a couple of these problems at the bottom. Like you have to know how to do this one. Okay, you remember in Algebra 2 and Pre-Cal when you did f of g of x? Okay, so that's usually a lot of algebra right there. It's like where you plug a function into x. So what we can do instead is take f out, okay, so that it's at the beginning, and do f of the limit of the inner function. So you take limit of the inner function and then just do f of that number. And I can see up here that that limit was k, so this all turns into f of k. All right, so enough of all the super vague stuff. Let's do some actual examples now. So in example 1, we have a limit. We still have an unknown function, but this time I know that that limit as x approaches c of f of x is 9, and then I have another limit for a different function, and that equals -2. Okay, so I know those two limits. I don't know the functions, but I know those two limits. So if I wanted to say, well, now find the limit of 4 times f of x, I don't have an f of x to even multiply by 4, right? But the good thing is we have the property that puts the 4 out in front, and what you're left with is just saying, okay, well, what was the limit of f of x again? It was 9. And so this equals 36. So even though it's a lot of like to do, it's really not that difficult. And it's pretty, you know, it's not tricky. So what do you think about B? What are we going to do here? I can't actually add two functions that I don't know what they are. But I can add the two limits. This does not work for everything in math, by the way, but it does work for limits. And that's good news. All right, what about C? So y'all can talk. I'm telling you, the video will not pick up on you unless you just like scream it out. Or you're not sure what it is? You don't think that's the issue? Yeah, so this, without the power, is 9, right? Some of you are already giving me the answer. But 9 to the negative 3/2 is the answer. If this is free response, you could have left it just like this, and we could have left these like this. These do tend to be multiple choice a lot. So if this is multiple choice, we're probably going to simplify it. We haven't gone over this yet. So let's just do one thing at a time. So the negative, remember, puts it as a reciprocal. And then the 3 is a cube, and the 2 is a square root. Which one of these do you want to do first? Probably square root. Why? Yeah, who wants to cube 9, right? No one. Not me. Okay, so that ends up being 1 over 27, because square root of 9 is 3, and 3 cubed is 27. Either of these answers is fine. If this was multiple choice, though, 1 over 27 would be how the answer would be. It would be simplified. And we hadn't gone over that yet, so I wanted to spend a little bit of time doing that. Okay, so now we're looking at 2. Okay, we have actual functions now, so it's not as vague. So one thing we could do is actually solve for f of g of x, like get a whole brand new function, and then do the limit as x approaches 3. Or we could use our property, which let's do that. It's going to save us a little bit of work here. Let's put the f in front, and let's put limit as x approaches 3 of g of x inside. So that's using that property f up here. Now we have to use what we learned yesterday and actually find the limit as x approaches 3 of g of x. And so we got to come over here and think about, okay, well, what would that be? Here's g of x. And remember, our first line of defense is just to plug 3 in. So what do you think this limit is? 5. Yeah, you're doing 5 times 3 minus 10, 15 minus 10, that's 5. And now we're going to do f of 5, which is, you've done this a lot of times. Again, if this is free response, you do not have to simplify, although you could, although I have full confidence that you know how to simplify that, so we're not going to spend time on it. Okay, so far so good? Okay, so number 3, we have a limit as x approaches 1 of sine of f of x. We cannot just immediately plug in the 1. This is a function composition. One of the functions is just an f of x, the other one is actually sine. We have to use this property. We have to move sine out to the front. If you don't do that, you're going to end up getting the wrong answer. I mean, you could always luck out and get the right answer, but it's not going to be the same process. So we move that sine out to the front, and what we focus on is the limit of the inner function. And we have a graph here. We don't have an equation, but we have a graph, so the limit as x approaches 1 of f of x. Now this piece of this is something you know is going to be on Friday's quiz. So as x approaches 1, What are the y values approaching? 3, right? So we have a sine of 3. And if this is non-calculator stuff, you can't go any further than that. That's not an exact value you could even compute. If you had a calculator, you would just type it in and get a decimal. I mean, if that was multiple choice. But this is fine to stop right here. Okay, I want you to try to do 4 on your own. If you're stuck and need a hint, you can look up here. Okay, so what do we get? Natural log of what? 2, right? Not 3. Okay, so that's kind of all section 1.3. What we're going to spend a little bit of time now is just kind of going back over some limits from yesterday, making sure we're all good on the same page. So remember, you can solve them algebraically, like expressions and equations. You can solve them graphically or with tables. We're going to focus the rest of this time on this kind. So remember, you always are just going to plug it in first. You plug it in, and then if you get a number over 0, a non-zero number over 0, what is that limit? Does not exist. Graphically, why is that happening? A vertical asymptote. Okay, what if you get 0 over 0? You have to do more. Now, before today, that was always factoring. And this is always happening because of a hole. All right, so I want you to do 5 and 6. One of these is a does not exist. One of these is a do more. So go ahead and try those on your own, and then we'll do 7 and 8. If you finish 5 and 6 real quick, try 7 or 8. But then we'll do 7 and 8 together. Okay, I think everybody was at least able to get one of these done, and a lot of you were able to get both of them done. So what happened when you plugged in on 5 initially? What'd you get? 0 over 0. So this means we have to do more. So then I saw a lot of factoring. So that would be x minus 5, x plus 2. Over x minus 5. We saw some canceling. That was good. And then some of you, there were kind of some different things I saw with different people. What you need to do after this is plug in again. So this is going to be 5 plus 2, and your limit is now 7. And you could have left it as 5 plus 2, but it's pretty easy to add those numbers. Anyway, you don't actually have 0 at the bottom. When the reason we canceled, like x, when you do something divided by itself, what is that? 1. So there's really a 1 in the denominator. That's a great question. Okay, so then on number 6, when you plugged in, what numbers did we get? 27 over 0. We don't even have to factor anything here. This limit does not exist because graphically there is a vertical asymptote happening at x equals 5. So we have an unbounded behavior. That was one of the 3 reasons the limit doesn't exist. All right. Now 7 and 8 are a little bit more difficult. Let me just tell you, neither of these are on this Friday's quiz, although definitely on the next quiz or test, these types of problems could be on there. So some of you, it depends kind of, some of you are going to get this faster than others, but everybody will get there eventually. All right. Plugged it in first. What do you guys get? Yeah, you get like 1/5 minus 1/5 over 0. So 0 over 0. So we do more, except this doesn't factor. So we have to come up with something else. So this is what I'm going to do. I'm going to first start off by rewriting the problem. And next, I'm going to do something we call multiplying by a clever form of 1. If you multiply by 1, everything stays the same. It just looks a little bit different. Okay, and so in this case, what we're going to multiply by is the 2 denominators, because that's going to cause things to cancel in the next step. I don't know why that keeps doing that. It's okay. All right, so I'm going to multiply 5 and 5 plus x. And I got to do that to the bottom and the top, right? Because we're really multiplying by 1. I got the 5 and the 5 plus x from these 2 little denominators here. Okay, let's just, for good measure, let's go ahead and put some parentheses here in this term. And what we're going to do next is some distributing, and hopefully something will cancel after that. So this 1 over 5 plus x, when that gets multiplied to 5 times 5 plus x, the 5 plus x's cancel and you're left with just 5. It's like, you're like going here and then here. Okay, then there's a minus. Now, whatever I write next has to all be subtracted, so I'm going to go ahead and put some parentheses there. What happens when you do the 1/5 times the 5 times 5 plus x? The 5's cancel, right? And so you're left with 1 times 5 plus x. So I put this in parentheses. I just got to make sure somehow I know that everything is being subtracted, this 5 and this x. Okay, the denominator, I'm just going to rewrite. Now you might be thinking, ooh, I see stuff that cancels, like the 5 plus x's cancel. Well, you may or may not remember that these pluses and minuses, you can't break them up very easily. All right, so I cannot cancel out these 2 terms, top and bottom, nor these 2 5s. What I can do is distribute that negative, though. So that's what I'm going to do. I'm going to go 5 minus x. I'm going to distribute the negative to both of these terms and then just rewrite the denominator. So this is definitely more work than just factoring. Okay, I still can't cancel something from the top with something from the bottom, but 5 minus 5, what is that? 0. Okay, I know that. I know I can do that. And now the only thing I have on top is a negative x. So now I can cancel this x with this x because I'm not breaking any major terms up. This times right here is totally okay to break up. It's pluses and minuses that are the problem. What do I really have left on the top now? Negative 1. So let me just go ahead and rewrite what I have. And what we're hoping, and we did do it, is that we canceled enough stuff out so that I won't get 0 over 0 again. Okay, if I plug in and I still get 0 over 0, I didn't do enough. All right, but it's going to work out just fine because we're going to get negative 1 over 5 times 5, which is negative 1 over 25. You didn't have to simplify it all the way down, but you had to at least plug in the 0. Okay, so more work, but if you saw this one again, it would be easier than right now when we did this for the first time. Okay, number 8. Okay, again, we're going to try by plugging it in. If we plug 0 in, we end up getting square root of 1 minus 1 over 0, 0 over 0 again. So this means do more. And again, factoring doesn't really help me. That doesn't factor. So I'm going to rewrite the limit. And I'm going to multiply by a clever form of 1. Anybody have an idea of what I can multiply by?
X plus 1 squared.
So what were you going to say, Peyton? Yeah. Do you know what that's called? It's called the conjugate. Like basically the conjugate of a plus b is a minus b. And anytime you're dealing with radicals, this is a way to kind of get rid of those radicals. So I got to make sure I do that down here as well. Always multiply by something over itself. If you're still not super clear on why this is going to work, stay tuned, I guess, because you're going to see in the next step. All right. Okay, so if I put parentheses around this, I think it might make it a little bit easier to see. So I'm going to multiply square root of x plus 1 times square root of x plus 1, which is just x plus 1. Okay, then I'm going to multiply square root of x plus 1 times regular 1. Then I'm going to multiply negative 1 times square root of x plus 1. And then negative 1 times 1 is negative 1. And again, I am just going to rewrite the denominator. Not going to do anything to it yet. Okay. We're not looking yet to see what in the top cancels with what in the bottom. We're really just trying to simplify the top. So do you see anything that's going to cancel? Yeah, the square root of x plus 1 and the minus square root of x plus 1. The plus 1 and the minus 1. And now that this x is the only thing on the top, now I can cancel it like that, and there's like a 1 on top. So if I rewrite, I have this, which is much simpler than what I started with. It doesn't seem it, but it is. And I'll know for sure that it worked when I plug in. So now I'm ready to actually, and by the way, notice I have not yet taken the limit. I'm about to. But until you take the limit, you got to keep writing that limit as x approaches 0. Now I'm ready to plug it in. And so you're fine to write that as your answer. This does simplify to 1/2, which is what the limit is. Okay, so definitely more algebra here. Same process as what we did before, just more algebra. Hardest part of calculus is the algebra.